Alright guys, so I'm back with another video. I'm going to show y'all how to do these walls like this or like this. Now I'm getting about 110 FPS right here right now, 120, but without recording I'm getting about 150 solid, stable. So I used the same logic for this, and for this. I just modified this one slightly. I think we'll look into that. But yeah, basically, I'm going to show you how to do all this, even how to make this, and you'll see that it even works on this one. You'll see on this one that actually I'm just using a mesh, and I made this myself using the Quixel Megascan materials and the modeling tools. So I'll go into that at the end of the video. Right now I want to try to focus on the task at hand. So I will be referencing my work when I need to, because I don't have a whole lot of experience doing this, and I don't want to have to keep redoing this video over and over again. This is an optimized version of this wall. I merged these actors, so yeah, you can select two meshes, for example, and even if it's a PCG, you can go to actor and merge actors and merge to merge them. So that's how all of that is done. Now I'm only using about 5 different bricks right here, and you'll see some patterns or some that are similar, that are side by side. But since I'm only using 5 meshes, that's almost unavoidable. So just keep that in mind. Also over here, I only have about 5 bricks of this nature, and 3 of those are tiny half-size bricks. So I weighted the placement of these meshes, as well as using that graph. I have not yet figured out how to procedurally offset varying meshes of varying sizes yet. I don't even know if that's possible. It probably is. I'm going to look into it and we'll revisit this later. But for meshes that are fairly the same size, this should work. But as you can see right here on this one, because I had to put them so close together to close the gaps, some of them are overlapping. If I move these, you'll see it just randomly places these. Yeah, so same with these. But yeah. So anyway, let's get into it. Now that the intro's out of the way, the first thing we're going to do is we're going to create a folder, and I'll just call this example. And we need to create, well, first off, I'm going to assume that you probably haven't used PCG before, so let's just start from there. We're going to go into plugins and just type in Procedural Content Generation Framework, PCG, and check that. You'll have to restart your engine. It'll pop up over here and just say restart now. After you've restarted, you can come in here. You can go over here to this button here and go to Quixel Bridge, and then just go through here and find some assets. So I'll show you the assets that I used under industrial. I used some of these. I don't know why that's this Quixel Megascan thing is lagging, but it is. So you can come over here. It seems to be my internet. I think that's what it is that's lagging. So anyway, let me just come over here to these collections, see if this is any better. Okay, so you can search for like wooden pallet or concrete brick, for example. Those are the concrete bricks you see over here. the let me see if I don't know why that's lagging. This material right here, the damaged concrete, is the one that I used for that mesh. Damaged wall is what it's called, actually. So that's the one I used for that. I'll go over how I made that in the end, as well as merging this into this actor over here, which was significantly reduced in triangle count from something like 1 million something, or maybe several million, all the way down to 250,000, and you'll see it still looks good. But you might want to do yours a little different because of the way I did mine, the order I did it. I ended up with some gaps here and there. I'll explain how to avoid that later. So anyway, after you've restarted, you've gotten your Quixel assets or whatever assets you want to use, it doesn't really matter. Then we can go ahead and get started. So we're going to go back into that folder we created, and we're going to right click, and you should have a PCG thing here now. If you don't, then you might want to check and make sure you enabled the correct one. You can rewind this to see exactly what it was that I had checked. Go to PCG Graph. PCG Graph, it's the only thing you have available. We'll just type in PCG wall wall stack or something. Yeah, whatever. Anyway, open it up. And you'll see the input and output. Ignore that. You don't actually really need that for this example. We may go into nested PCG graphs later, but I'm not going to go into it in this one. So the first thing I want to point out is that when you do use, because this is something that a lot of people haven't caught on to yet, so I want to go ahead and point it out. This right here, this N, is deprecated, which means they're going to remove it. And this input is also deprecated, which means they're going to remove it. This one, this one, this one, this one. So I'm going to show you how to do that real quick. So what you're going to do is, if you ever need to use any of these for the landscape, you can say get landscape data. It's under the spatial category. And that's how you'll get your landscape data from now on. Don't use this because next update it's going to break it if you do, and you'll have to go in there and do this anyway. So may as well do it now. Also with these inputs, you're going to press this button right here. It's going to create an array. You're going to see a new pin here. By default, it's any type, but you're going to want to switch it to the type that you need. A good way to know is, say I want to sample some surface points, and I want to pass those surface points in from the parent graph that I've put this graph under. Then I would want to move my cursor over this, and it'll say the subtype is surface data. So I'm going to come back over here. I'm going to look for surface data. In this case, yeah, it's right here. It's surface. So if it says volume data, it'll be volume, primitive, so on and so forth. You can pass in primitive objects as well and place points around, sample points around that primitive object. That might be something I go into in a later video, but there's videos out there already for that. What I'm doing today is I'm showing you guys some stuff that nobody has gone over yet, or that only one person has gone over. I will leave a link in the description to somebody's video or YouTube page, and that's watching his videos is actually how I figured out finally how to do this, what I'm about to do. So what we need to do first off is we're going to create a grid. So we're going to type in create point grid, points grid right here. And the grid extent is how far out it'll generate this grid. And the cell size is basically how the dimensions of these points, like how spaced apart they are. So if you had a brick, you would want to put the dimensions of the brick inside of here so that these points would be spaced out by that amount. And I'll show you that here in a minute. Also, when you create a point grid, I'll go ahead and you can press D or right click and select debug, and that'll allow you to see it in the viewport. First off, we're going to go back into the folder where we saved this at, and we're going to drag this into the scene. And it looks like my engine is a little bugged out right now. That's why you don't see the box, but yours should show a box. Now we've debugged this, but we're not seeing anything. But if we go over here to the world origin, we might see it. Let's see. Oh, wait. We have to come over here, and right now it's cull points outside volume. I'm going to uncheck that just to show you guys this, and you'll see that we have these little points over here, and they're all at the world origin. So that's what it does by default. So if you drop this into your scene and you don't see any of those points, that's because those points are being generated at the world origin, and if you go there, you're not going to see it because by default it also culls points outside the volume. So I hope that they fix that in a later, because I think by default it should be local. Just check local here, and when you check local, you'll see that these points are now being generated inside of that box. I'm going to go ahead and restart this real quick because mine's bugged out. So just give me a minute, sorry. I don't want y'all to get confused by the fact that you can't see the box on mine. So now you can see the box. This is the box. So when you drag this out into the world, by default it gives you this big huge box that has the dimensions stretched. I would suggest just pressing this reset button here to put it back down to size. And when you do that, your points may disappear. They'll probably disappear, but that's fine. So we'll come back over here, and the reason why they disappeared is because they're so big. And if we do 10 by 10 by 10, let's see. Oh wait, no, it's because I'm not debugging. Sorry about that. Yeah, so it wasn't the size, but you'll see that it's only drawn 4 because the rest of them are outside this box. If you need to make this box bigger, I would suggest going down until you get to the brush settings category and increasing the size of this to whatever it is you want. And you'll then see more of those points. But I'm just going to leave it at 200 for now. And we're going to come back into here, and we are going to go to this coordinate plane axis, and we're going to say, I think it's XZ. Let's see. Yeah, so you'll see now they're going up and down. So for this example, I'm going to show y'all how to do stack some bricks. So I'm going to go over here into the Megascans folder and go to 3D assets. I'm going to filter out static meshes. You can create a filter right here, and it'll automatically put it into this filter box over here. So yeah, we'll just use some of these concrete bricks here. And the average size of these are 20 by 10 by 8. You see the approximate size there. You can also open it up in here, and you'll see the approximate size right here. So you can do it either way, but if you just move your mouse over them, you'll see this is about 20 by 10 by 8, 20, 10, 7, 20, 10, 8. So we can do 20, 10, 8. So we'll come back over into our PCG graph and we'll say 20, 10, and 8 for our cell size for right now. You can also offset the grid center, but we're not going to be doing that. This is where you determine how big, how far out it'll draw it. So right now you'll see it's fairly big, but if we decrease the Z, for example, down to 100, let's try 10, yeah, okay, about 50, and you'll see something like that. And you can also do all of these like that if you want. This right here would be the Y, and you can tell by selecting this box or selecting these points, and you'll see that the green is the Y, the red is the X, and the blue is the Z. So it's X, Y, Z, and this is X, Y, Z. So anyway, I just wanted to make sure that you guys understood that. So with that out of the way, we'll go ahead and I'm going to make this 100 units wide, which is wider than this box, I think, but that's okay. We can extend this box since, oh, okay. See, if we do 225 here, you'll see that is actually where it stopped, because it goes 100 from the center in either direction. So now we're going to come out of here and we are going to do a density filter. I'm pretty sure that's what we do. No. We're doing a, let me see, a dense, okay, yeah, we could do this one first, the difference. So if y'all want to do that one first, we'll go ahead and do that first. Actually, you know what, let's do that last. We're going to do the density noise, and then we'll make our blueprint right here. So we'll type in density noise, and you'll see that it doesn't come up here, and that's because it's actually a blueprint function that is not exposed to this list right here. So go to execute blueprint under the blueprint category, and then over here under the blueprint element type, type in density noise. And this works just like those functions that you use inside of a material graph, a material shader graph. It works the same way, where you can import blueprint functions. So, or I should say material functions. So anyway, now that we have our density noise, we're not going to change anything on this. We don't need to. What we're doing is the density mode is set, so we're setting the value between 0 and 1, and it's going to be random. And so we can press D on this one and undo that one, or right click and debug. And when you minimize, you should see that it has broken up the density of this, and that is represented as color. So white is 1, black is 0, and then the grays are in between 0 and 1. And that's just so that we can, you know, if we want, actually I'm not even really using that, so I don't think, yeah, so it's actually kind of pointless. In this case, we actually don't need that. But if you wanted to, what you could do is then do a density filter if you wanted to add more variety to that. And you could do a density filter, And what you could do is you could invert this filter. By default, it's 0.5, which is gray to white. And if you invert it, then it's gray to black that it puts out. And so if we come over here and we show this one, you'll see what it's doing. And then what you could do off of here is you could do a transform points under spatial. And you could give it a min rotation and a max rotation. If you check absolute, I think that will set the rotation directly instead of additively. Okay, yeah, so instead of adding this to its current rotation, it will actually just set that to be that world rotation. So that's what absolute rotation means. It means that this will be its actual new world rotation, or maybe its new local rotation. I haven't experimented with that. So you could say 0 to 90 here, and then you could say 90 to 180 here. And so now all of these would be randomly rotated. Let's see. If we used this output function just for demonstration purposes, I'm going to disable this. And so you'll see it would do something like that. So that's the built-in method that people use. So it randomly rotates them, and I realized that in certain cases, like whenever you're trying to put together walls and stuff like that, you need to have a more controlled way to rotate things rather than randomly rotating them. You could do 180 to 180 and 90 to 90, and then you'll see that they look to be even, and you can do it like that, but it's not quite as controllable because this density noise, it randomly generates noise. It doesn't generate noise in patterns. I might go back over, and I might end up doing another video where we do what I'm going to do with the actual point rotation and transforms, but I might do that with noise instead, so that we can break up the noise using this same algorithm. And you could probably figure that out yourself, because something I haven't mentioned yet is you'll notice that these are purple and these are blue. Well, this is pink, this is purple, and this is blue. So if we try to open up the purple one, it wants to open it up inside of a inside of a programming software. But these right here, the blue ones, are actually stored in an actual blueprint, and you can come in here and look and see how they're doing it. All the other colors that you'll see in here, those can't be opened up inside of here. You have to open them up inside of like Visual Studio or Rider or whatever. So I just wanted to show you guys that before we really got started. So we'll go ahead and delete these, and now what we need to do is we need to actually create our own version of this. And so what we'll do is we'll come back into this folder and we'll right click and we'll do blueprint class, and we'll say under all classes, you'll have to expand this because by default it's like this. You'll have to expand it and then search for PCG Blueprint element, and then just select that and select, and we'll call this BPCG. I guess maybe that's not a good naming convention. I don't know, but anyway, we'll call this. What should we call this? Modify Nth transform. That's what we'll call it. And so now we'll open this up, and you'll see that we have these class defaults over here. We want to expose this to the library, and we want to specify a category that we want it to be placed under. Now you can just say custom. That's what some people are doing, and it will show up underneath a custom. So if we come back over here, if we right click, we now have a new one called custom, and so you'll see that this BPCG modify nth transform now shows up under it. So yeah, you can add a description too. Like that. You can select, you can make these multi-threaded. I don't know if we can do that with this one. I assume we can, but I'm going to disable it for now. We'll try it afterwards, and if it crashes or gives us an error, then we'll know if it works or not. But under here, under functions, there's 11 overridables. You have an execute with context. The execute functions that you can override, that's actually what gets called on this right here. So you have execute functions, and then you have an iteration loop body, nested loop body, point loop body, and variable loop body. Those are loop bodies that are set up in C++, but you can override them here. And so what you can do, what I've been seeing a lot of these are doing, is they're using the execute with context, and then they're calling these loop bodies using a built-in function that allows them to pass something in, and then inside of C++, they're doing something where they're splitting it up or whatever into different, for example, if we come over here to the point loop body, it's splitting this up. But if we go to execute with context, if we wanted to call that, we would say point loop. We would call PCG flow control point loop, and you'll see it takes in different stuff than what that does. Now for ours, we're not going to be using the point loop body, but I'll go ahead and explain to you what the difference is, at least between the point loop body and the variable loop body. So the point loop body allows you to modify a specific point, and then the variable loop body allows you to add more points to this. So what some people are doing is they're creating a grid on the ground, and then they're bringing this in, and they're creating something off of the variable loop body, and they're adding points recursively to each of those points on the grid, so that you get these spiraling towers coming up off that grid. That's what some people are doing. That's just an example of how you can use it. Now, the only reason why I can't use either one of those is because I soon discovered that there's no way to get an index or to pass an index into this or get an index out of this from inside of these functions. So you can save these as variables, but then when you try to access them inside of these functions, it just doesn't seem to work. And that's what I struggled with all day yesterday, trying to figure out how to use these specifically to do this, and I could not do that. And so we're going to do all of our stuff right here from the execute with context. And yeah, that's what we'll. All right, so if you don't know how to do that, come over here to override, and right below execute, you'll see execute with context. Just override that, and you'll get this graph here. So the first thing we're going to need to do is we're going to need to break the PCG data collection, and that'll give us our tagged data. Now this is going to be the data that we're iterating through. So we're going to do a for each loop off of that. The tagged data, I'm not going to go into too much detail about that because I don't know a whole lot about it yet, but I do know this is what we have to access before we can do our loop to iterate through our elements, our points. So off of here, we need to get the we need to break the PCG tag data, and we need to cast this to spatial data, PCG spatial data. And off of this, we need to do a 2-point data with context. This will convert it to or this will get the point data with context from it, or convert it to it. Now we need the context off of this, so we'll right click and we'll say in context, and we'll scroll down to the very bottom and get in context. And you can copy this if you want, because we'll be using it later. We'll be pasting it other places later. So off of here, we want to promote this to a local variable, and we'll just call this looks like I already had one. I'll set this one then, and we'll call this PCG point data. Now off of this, we need to get the points, get points from the spatial data. This will give us an array, and we should be able to promote this to a variable. So we'll promote this to a local variable, and we'll call this PCG points. Let me just make sure I'm doing this right. Yeah, okay. And then we need to iterate through this. We need to break the PCG point, get the transform from it. We'll do our math. We'll set the members, and then we'll add that. We'll set that back to the array element. Not 100% sure why we have to do it this way, but if we don't do it this way, then it doesn't seem to work. And just setting the member doesn't seem to finalize it, so we have to actually set the array element afterwards. So we'll hook that up. And I'm just shift selecting the second one, and then I'm pressing Q to align them. Then I'm going to do a for each loop off of here. And so for each of these, we're going to get, let's do a break PCG point right here. And we can disable everything but the transform, because that's all we actually need off of this. And then we're going to set members in PCG point. and we're going to expose the transform because that's all we need to set. And then we're going to set the array element. And we're going to use the PCG points right there. And for the index, we're going to set that back. Now this is where we could create our own macro. You don't have to make this as a macro, but I'm going to make mine as a macro because it's cleaner. It's kind of redundant because macros are normally used when you have the same stuff used in multiple locations, but in this case we're just using it in one. So first off, we're going to need a variable. We're going to call this the offset transform. And we're going to change this to a transform type. And we're going to make this public variable or instance editable. We're going to drag this out. And we're going to break this and break this. And we're just going to add these two together. And then for the rotation, we need to break rotator, and we need to break rotator. And then we need to add each of these together. And then we're going to make rotator. And then we're going to make, well, we don't necessarily need to make the transform, but let's make the transform for now. And we'll plug that in and plug that in. And then we'll plug this into this, and then we'll select all of this. And we will collapse to a macro, and we will call this add offset, add transform offset, and then select this macro, and we'll rename this to transform point transform and offset transform. And you can rename the return value if you want, but I'm not going to. And then inside of here, we can break this and split this, and then just connect to this, like so. You can hold down Shift and click if the highlight gets stuck. And so there's our macro. We're just adding stuff there. But we want to select a transform based off of some math. And so if, let's see, if this index modulo, you'll see the percent integer. If this if this index is divisible by 1, then every one of these will be rotated. If we want it to be every two of them, if we want every two of them to be rotated, then the value would be 2. If we want every 3 of them to be rotated, then the value will be 3. Simple math. It's a cool trick that's it's actually very common to use this trick in programming. So that's how that works. Basically, if the number is divisible by 2, it'll always return a remainder of 0. Because 2 divided by 2 has a remainder of 0. 3 divided by 3 has a remainder of 0. 9 divided by 3 has a remainder of 0. So on and so forth. So we're going to promote this to a variable, and we're going to call this nth element, or name it whatever you want. So we're going to make that public, instance editable, and if this is equal to 0, then we want to select this transform. Also, 0, anything divided by 0 will have a remainder of 0. So keep that in mind. If this is false, then we just want to use the regular transform that's already set for it. We don't want to alter it, so we'll just pass that through. And so with all that out of the way, now we can go ahead and start finishing up here over on our complete. So what we need to do, I have to remember exactly what we do here. Oh, it's off of this complete, right? We have to do this and then we finish it up right here. So we need to set the points on the PCG data, PCG point data, and then we need to add this PCG point data to the PCG tagged array. Now, we have not created the PCG tagged array yet, so I'll go ahead and off of this output I'll say make PCG data collection, and I'll plug this into the complete. And we will promote this to a local variable, and we'll call this PCG tagged data. And then over here on this, we'll get our PCG point data, and we'll set points under spatial data category. And so this array right here of PCG points that we created, we will set those as the points. And then we need to get this, and we need to add some items. We need to add the PCG to that. We have to make a PCG. Make PCG tag data. And hook that up. Alright, so let's see. Now, I don't know if this is necessary, but I mean, I've seen other people not do it, but I'm going to go ahead and do it. I'm just going to plug in this stuff into here. something like that. That's pretty much it for this. Oh, no, we still have one more thing. Okay, so go to override, go to, I believe it's node title override. Let's see. Yeah, node title override. We'll override that, and this will be the name that it shows up as inside of our PCG graph. It'll be the name right here. And so we'll name this modify every nth transform. And then save that. And that should work. So now that we've got that, we can go into the folder where we have that at. Actually, we don't need to. Just go back to your graph here, and then under custom, you'll see that PCG. So what we named it right here is what it'll show up as in this list right here. But the actual title of it in here will be what we overrode it with under the node title override. So you can match those names if you want. I might actually go ahead and do that myself. And so when I come over here, it should show up as that. So we'll just plug that point grid into here. And here's the stuff. By default, we don't have any rotation on it. The default is the second element. That's what I set mine to in there. The nth element. Actually, we should probably call that the nth point. So we'll just go ahead and try this out by setting it to 90, and then we will spawn some static mesh actors. And so under here, you'll see some mesh entries. You'll just add some elements there. Now the weight is an integer number. It's not a floating point. So it's not 0 to 0.1. It's 1, 2, 3, 4, 5, so on and so forth. So if you want to give something more weight, you have to give it a larger integer number. That's just the way they did it. So we're going to go back over here. Let's see. Looks okay. If your screen ever freezes like this where you can't rotate it, go into modeling mode or any of the modes and then come out and it should fix it. So I think I was going to use some of those bricks, or some of the red bricks, I guess. Let's see. Yeah, I was going to use some of these bricks. Those are the concrete bricks. And so we'll just go to the description, and under static mesh, I'll just add that. Now it'll randomly choose which ones of these to place, I believe. I don't think we need to do a density noise function on it. In order to get it to do that, I think it will do it automatically. So I'm just going to add all of these. And you'll see every other one is rotated. And so as you've noticed, it seems to be doing it in columns instead of rows or whatever, but that's because it starts from left and then goes right, left, right, left, right, and that's how. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, so on and so forth. So that's why what you're going to want to do probably is use 2 of them in a row. Except on the second one, we're going to do, let's say, every third or fourth point. It's up to you. It looks like something's messed up here. Wait, I think it's... Oh, right. So we'll do 180 and 180. Yeah. Alright, looks like I might have to debug this. I'll be right back. Alright, I figured it out. So it's the input and output, and we were missing something, I believe. So come back over here to our blueprint element and go to the class defaults and uncheck has default in pin and out pin. Uncheck both of those, and then add an array to the custom input pin and the custom output pin. We'll call this one input. We'll set it to point. And on the other one, we'll call it output. And we'll set it to point. And we'll go ahead and try this just to see. But I think we need to use density noise. Yeah, I'm not real sure exactly why we need to use density noise, but this won't work unless we use density noise. So go to Blueprint, Execute, and then drop down the Blueprint element or list. Type in density, and you should say density noise, third from the top, and then we'll plug that in. And now it should work. Yeah, now it's working. So you'll see every third one. If we do 2, every second one. So what we'll do is we'll create another one. We'll copy and paste that one. I'll look into that and find out why we need to use density noise. I don't know why that would have an effect on whether we are able to modify the transforms or not. I wouldn't think that it would have an effect on it, but maybe for some reason it does. So we'll set that to 3, and we can do 180, or you could just do 180 on the Z on that one, which would spin it around where the back is facing the front, and 180 on X flips it upside down. So yeah, something like that. and it adds a little bit of variation to it in an organized manner. And you can use as many of these back to back as you want, but I don't think you really need more than two in most cases, or in all cases for that matter, but it's totally up to you how you want to do that. Also, if you want to mix up this, you could just move it, or I don't know if this will have much of an effect on it. No. I mean, you might be able to try messing with the density some more. I don't know if that even has an effect on it. It probably doesn't. I'm just going to delete this one. But I don't know why I have to start it off with density noise. There's got to be a reason. I'll look into that later, but yeah, that's basically it. I mean, all you have to do from here is expose this stuff. And so let's see, how did I do it on this other one? Get actor property, that's right. So this won't work unless you actually create a blueprint actor that contains this. So we'll go ahead and do that. We'll go to browser and we will create a blueprint class, just make it an actor, and we'll call this BP wall stack, or you can call it grid stack or whatever you want to call it. We'll call it grid stack. And then we'll open this up and we'll create, let's say we'll add a PCG component. And then over here in the graph, we're going to add our PCG graph, this one right here. And so now I'm going to go ahead and delete that one. And we'll drag our PCG grid stack blueprint out here. And so you'll see right now we don't have anything exposed over here, but we're going to expose that so that we can change these values from inside of this procedurally in the editor. So we're going to get actor property, and we need the property name. So you'll see over here on mine, I just used brick wall dimensions. We'll use wall dimensions, and that was a vector. And then mesh dimensions, that's also a vector. And then we need a new one. We'll call this mesh offset. Transform, or mesh transform offset, whatever you want to call it. We'll switch that over to transform, and we'll say Nth offset, Nth mesh offset, and we'll set that to a integer, and then we'll compile. If you get a compile error saying something about one of these whenever you do this, like I did because I did it in the wrong order, then just delete it and recreate it. The reason why it does that is because if you already have this property name set, then it'll be trying to grab this from over here, and it can mess stuff up. So we're going to copy and paste these into these property access things. And I'm just holding shift and left clicking right here. You can do that too. Those are the ones that we need. And we'll plug these into the grid extent and the cell size, because the wall dimensions are going to be the grid extent and the cell size is going to be the mesh dimensions that we need. You'll get an error right now, but we'll fix that here in a second. Now if you want to do it on each of these, if you want to change these on each of these, then you need to expose one variable for each of them. I was just doing it on the second one because I didn't think it was that important. Nth mesh offset and mesh offset transform. So let's see, I'm probably doing something wrong on these. Allow, you have to make these public, by the way. And then the errors will go away. You can also, oh yeah, that's instance editable. Okay. Now we should be able to, the default wall size is 0 on this. So what you might want to do is select this and copy these over as the default. Shift right click and shift left click, copies and then pastes. I'm shift right clicking to copy and shift left clicking to paste. There we go. And so there you go. You can change this stuff from right inside of here. Odd numbers are probably going to be more likely to make it look more varied than even numbers. So just keep that in mind. And there you go. If you want to create some, like if you want to be able to cut it out like this, I'll go ahead and show you how to do that. It's actually really easy. So first off, you need to create a blueprint class, make it an actor. We'll just call this PCG wall or BPCG wall cutout. And I'm going to copy wall cutout because I am going to add a tag under this. Just select the root component here and search for tag and add a tag to here and call it wall cutout because we're going to need that tag. And then we're going to say box collision, and there's your box collision. So that's basically it for that. all you have to do now is drag that out here, and then you have to set it up inside of this right here. So let's see, is it under simple? Right, get primitive data. You might be able to use a different one. I'll use get primitive data. It's under spatial, by the way. If you look under here, you'll see others. Get spline data, texture data, volume data, primitive data. You could probably have used volume data, but whatever. And then we're going to say all world actors, and by tag, we're going to enter that wall cutout tag. And we're going to check select multiple, because if we want more than one of these blueprints right here to be able to cut out using more than one of these, then we need it to be multiple. Otherwise, you would need to use this one blueprint to cut out the parts of every wall. In other words, you would need to make this bigger. But anyway, so we're just going to do a difference off of here. We're doing this at the beginning because there's no point in doing all this other math on these points if we don't want them. So that's why we're going to do this right here. It'll automatically convert it for you. We're going to change this over to binary. And so now you'll see we have a hole cut out in the wall, you know, for a window or whatever. We can rotate it to make it look jagged, like it's falling apart, or like it has a hole in it. You know, so yeah, let's see, what else was there? Oh yeah, okay, so if you want to do something like a pallet stack, you can do that too, but you're gonna have to duplicate your stuff, which is what I did. And I'm not gonna do that, but I will show you how I did it. So if we come over here to the pallets, you'll see I just duplicated that code that I did for the other one, except I entered different meshes here. Now I looked to see if there was a way to pass in an array of meshes to this, and as far as I can tell, there actually isn't a way to do that. So it's unfortunate, but you have to just duplicate this. That's the only way to do it. So that's basically what I did, and you'll see I'm rotating that one 180 right here. That's just the default value, but on the blueprint itself I'm not actually doing that. So let's see, if I open up the blueprint, you can see the default values over here. I set the brick mesh dimensions right here on, that's what I called it on this one, but on yours it'll be called under class defaults. Would it be class settings? Okay, I'm on the wrong one. I was wondering, I was like, what's going on here? Class defaults. So you would change this mesh dimensions to the general mesh dimensions of that one for now. We'll come back to this later, maybe at a later date. I'm going to try to find a way to procedurally offset this based off of varying assets. In order to do that, though, I would need to be able to access those meshes that are in that array from inside of here. And so far, I'm not really sure how to do that. I'm going to look into that and try to figure it out. And if so, then I'll make another video where I show how to procedurally offset those based off of that based off of their varying widths. But if you come over here to these pallets, it's 102, 71, and 14. You could get the average of that, but some of them are going to clip. So 102, that one's 124 and 118. And that one's 105 and 76 and 13. And so I think I just went with something like 102, 71, and 14. 102, 70, and 14. And so if we select this right here, you'll see that's what I did here. Is I just kind of I reduced this from 14 to 12 because that was kind of like the good in between, so that there wasn't any big major gaps between some of these, because not all of these are the same thickness. So yep, that's basically what I did. And I set the wall dimensions. I lowered the wall dimensions. Yep. So anyway, that's pretty much it. Alright guys, let's see. I was going to do one more thing. I was going to show you all guys how I did this over here, and I'll go ahead and show you. So if I just duplicate that, you'll see it's just a wall, and I deformed the wall. So I'll go ahead and show you how to do something like that. I guess we'll do it right here on this one. So it might be a little hard to do because of this angle here. So I'm just going to remove that, and we'll do it on this one. And so what we're going to do is we're going to go into modeling mode, and we're just going to do box, and I'll make this a static mesh. Keep everything like it is by default for now. We're going to set this to centered, and we'll try to center it on this, but it's not going to be perfect. And then let's see, 100, so we'll probably want to make this 200. Wrong way. We'll make that 10 for now. We'll make this 200. And we'll... Yeah, I kind of messed that up, didn't I? Now I can't adjust the... Yeah, I can. There we go. That's about centered. We'll say 8. And I'll say 95. We need to bring this down 1 unit. And this snapping is turned on, by the way. Snapping is turned to 1. It's set to 1. And then we'll just try to move. No, that's about center. Unless you want to manually adjust it. We could manually adjust it. We'll turn snapping off and manually adjust it. That's just too wide. That's the reason why it's doing that. So we'll make that a little, we'll do 195 instead. Something like that. Right. Okay. With that out of the way, we'll accept that as the dimensions. Now we'll come over to, let's say, model. We'll subdivide it. We'll turn this to bilinear. We'll change this to interpolated. You can do generated, I guess. I'll do interpolated. We'll do 8. And if you want to, I know it's a lot, but We can reduce it later. So you'll see if we check new polygon groups, you'll see these are all the polygons, all the different colored ones. A lot, I know, but what you can do then is you can accept it. It'll make it a mesh. Download your Quixel bridge material from over here. I'm going to come over here and I'm going to open up this mesh. This is important actually that we set the mesh material from right here. So the reason why is because Lumen will look on this. It'll look at this. It won't look at that instant, the material on that mesh instance inside the world. It'll look on the actual one stored on file. So that's why we have to change it here. A lot of people don't realize that, and they'll do it only on the instance. So I'm going to assign that there, and I'm going to zoom in, and you'll see the UVs are a little bad. So we'll come over to the UVs, go to project UVs. We'll go to box, and I will say something like, because I already know that it's probably going to be about 50, 50, 50. And so if we see on all sides, we don't get no stretching on any of the sides now. Looks good to me, I think. So we'll accept that. And then we're going to go over here to deform, displace. We'll go to texture 2D map. We'll set this to 1. We don't need it to be a high value. And we'll set this to about 0.8. That's going to be how much offset it is around the edges. If it's too low, you'll see it. It might be hard to tell, but it'll give it some funky edges if you set it too low. So I'll set it at about, and if you set it too high, it'll give funky edges too. That's why by default it's set to 0.5. You don't see anything right here actually because let's use the ORD texture. All of the Megaskins come with this. The first one is occlusion. Occlusion is a grayscale, and that seems to be good. The grayscale is on the red channel, so it's red, green, blue. ORD, red, green, blue. So roughness is on the green, and displacement is on the blue. So red seems to work best. So if we come over here and we set this to say 0.2, you'll see what it does to the edges right here. That's why I set it to 0.8. That seems to be about right. But if you look closely, the edge looks a little sharp. So, I mean, you can mess around with that, maybe turn it down a little bit. But I think 0.8 is pretty close to accurate right there. Now you might be saying, okay, well, we have all this hidden geometry. Yeah, well, we'll deal with that. So just go ahead and say accept. And then select that wall. You might have to zoom in, select that wall, and select the PCG brick wall. And then go to actor, go to merge actors, it should say 2, and then say merge, and then merge. This may take a minute. It's a lot of detail there. Actually, that was fairly fast. So we'll drag this out into the world, and I'll show you what I did on that other one. It does create holes, but if you tweak the values, then you might be able to get it to do it without generating holes. Or you could take this you could export this and do this in an external program that's more developed than the modeling tools in Unreal. And you'll see this is pretty laggy, but we're going to reduce it and everything. So you'll see we still have all this geometry that will never be seen. And so we'll come over here, we're still in modeling mode. We'll come over here to mesh, and we'll say jacket. This will remove hidden triangles. I think this right here You can do raycast occlusion samples. Maybe that'll be better. We'll see. Let's check for holes. Yeah, I see some holes right here. That's why I'm saying this one's probably not the best method for doing it, because it will generate some holes in places, as you can see. I don't know if that'll make a difference. It made it worse, actually. Oh, only self-occluding. Okay. Nope, that undid everything. So now you'll see it has removed it, but like I said, it creates holes in places. I'm not real sure how to fix that. You'll just have to mess around with it yourself, or like I said, export it into another program. But you'll get something like that. I'm just doing this just for demonstration purposes, really. So I'll go ahead and accept that. That'll reduce the triangle count greatly, and then we'll reduce it some more. This is like 2 videos in one here. Actually, several videos in one. Okay, let's go to we'll go to remesh, and we'll go to shape preserving, and let's just set this down to something ridiculous like 50. It doesn't really matter because it'll reduce it as much as it can, and then it'll stop. Actually, no, it reduced it quite a bit. So I mean, you could do something like that, but it's probably actually better to do something like 100,000. You could also remove the smooth rate if you wanted to, or increase it if you wanted it to be smoother. But yeah, you'll get something like that. It'll still have some roughness to it. And again, you're probably going to get better results in a proper software. Something like ZBrush would probably be more preferable for this kind of thing. So actually, yeah, I would definitely say ZBrush would make this job a lot easier, and it would probably come out looking a lot better. But anyway, I'm just doing this for demonstration purposes. You can mess with the edge constraints, boundary constraints, all that stuff if you want. I wouldn't recommend discarding attributes. That's going to discard stuff like UVs, and it's not something you want. But then, you know, afterwards, you have these holes. Holes are not easy to fill inside of here because you have to manually select the holes you want to fill. I don't like that. ZBrush makes it a lot easier, so does Blender. But anyway, you can go to the browse and you can turn this nanite if you want. Anyway, that's pretty much it, guys. So if you enjoyed this video, found it helpful, all that, you know, I'd appreciate it if you would leave a comment down below. It does help the algorithm, and like, and, you know, consider subscribing. So anyway, that's pretty much it, guys. I'll see you in the next video.